In this video, we will learn how to find tangents and normals to a curve. First of all, let's understand what tangents and normals are. Consider a smooth curve y equals fx. Then at any point P on this smooth curve, we can draw a straight line which touches this curve. And this straight line is called the tangent to this curve at P. At the same point, we can draw a straight line which is perpendicular to this tangent. And then this perpendicular line is called the normal to this curve at P. Suppose the x-coordinate of point P is k. Then when we learn differentiation, we have learned that the slope of this tangent is just equal to the derivative of this function when x is equal to k. And then for the slope of this normal, since these two straight lines are perpendicular, and therefore the slope of this normal is just equal to minus 1 over f prime k. If the coordinates of the point and the slopes are known, then we can easily find the equation of the tangent and the normal by considering the point-slope form of a straight line. This is basically how we can find the equations of the tangent and the normal of a curve. But we should note that there are some special cases. The first special case is that a tangent may be horizontal, and in this case the normal is then vertical. In this case, the slope of the tangent has to be equal to 0, and in this way the equation of the tangent is just a horizontal line, which means it is y equals fk, and fk is the y coordinate of this point P. On the other hand, for the slope of this normal, it should be undefined because we have over 0 here. In this case, because we know that it is a vertical line, then we can write down the equation as x equals k, and k is the x-coordinate of this point P. That's the first special case. And the second special case is that sometimes the tangent may be vertical, like this. If the tangent is vertical, then the derivative at this point has to be undefined. And then in this case, the slope of the tangent should be a vertical line. That means it is x equals k, and k is the x-coordinate of the point P. And then the normal in this case should be horizontal, and then we should know that the slope of this normal is equal to 0, and as a result the equation of this normal should be y equals fk, and fk is the y-coordinate of the point P. Now let's take a look at some examples to see how we can find a tangent and normal in different cases. In this example, the given curve is y equals x times the cube root of x minus 4 plus 1. And then these 3 points are the points on this curve. And now we should find the equations of the tangent and the normal at these 3 points. First of all, we should find dy dx. And to find dy dx, we can apply the product rule. That means we can first of all take out x, and then we differentiate this cube root of x minus 4. And then we can take out this cube root of x minus 4, and then we can differentiate x. And then this plus 1 is a constant, so after differentiation it is equal to 0. And after simplification, it is equal to 4 times x minus 3 over 3 times x minus 4 to the power 2 over 3. Then for part A, we can immediately find the value of dy dx when x is equal to 5. And this is the slope of the tangent required. Then the equation of this tangent according to the point-slope form, it is this. And after simplification, the equation is 8x minus 3y minus 22 equals 0. Then for the equation of the normal, because we know that the slope of this normal is minus 1 over 8 over 3, as a result it is equal to minus 3 over 8. Therefore the equation of the normal is 3x plus 8y minus 63 equals 0. In part B, we should find the value of dy dx when x is equal to 3. And according to this result, when x is equal to 3, the whole thing is equal to 0. And that means the slope of the tangent should be equal to 0. I can show you the graph in this case to give you a better understanding. When the slope is equal to 0, that means it is a horizontal line. And then in this case, it is the tangent. And as a result, the equation of the tangent is y equals minus 2. And minus 2 is the y-coordinate of this given point. If the tangent is horizontal, then the normal has to be vertical. And if it is a vertical line, then the equation is x equals 3. And 3 is the x-coordinate of this given point. And then for part C, We should first of all find the value of dy dx when x is equal to 4. According to this result, when x is equal to 4, that means the denominator is equal to 0, and as a result, the whole thing should be undefined. If the slope of the tangent is undefined, that means the tangent is a vertical line. And if there's a vertical line, then the equation is x equals 4, where 4 is the x-coordinate of this given point. When the tangent is vertical, then the normal should be horizontal. And as a result, the equation of the normal is y equals 1, where 1 is the y-coordinate of this point. Finally, let's take a look at this example and see how we can find the equations of the tangents from an external point. In this example, we want to find the tangents to this curve y equals x cubed plus 7, which passed through this external point 1, 7. We call this an external point because this point does not lie on this curve. And now we want to find the tangents which pass through this point. This kind of question is usually tough to answer. And our common strategy is to first of all consider a movable point on this curve, and we can let this movable point be t and t cubed plus 7. That means when x is equal to t, the y-coordinate should be equal to t to the power 3 plus 7. Then by considering differentiation, we should know that when x is equal to t, the derivative is equal to 3t squared, and that means the slope of this tangent should be 3t squared when the x-coordinate is equal to t. Now we want to move this point such that this red tangent will pass through this point 1, 7 at certain values of t. We can also consider the problem in this way. Suppose we join these 2 points to obtain an orange straight line. Now we want to move this point such that this red tangent will overlap this orange straight line, and in this case, this is the tangent that we are looking for. Now we know that the slope of this red line is equal to 3t squared, and we know that the slope of this orange line is equal to t cubed plus 7 minus 7 over t minus 1. And now we just need these 2 slopes to be equal to each other, and then we solve for the value of t. And as a result, we can get that t should be equal to 0 or 1.5. That means that there are 2 cases. The first case is that when t is equal to 0, and this is the tangent that we are looking for. And in this case, dy dx is equal to 0. That means it is a horizontal tangent. And if it is horizontal, the equation is y equals 7, where 7 is the y-coordinate of this given point. The second case is that when t is equal to 1.5, and this is the tangent that we are looking for. In this case, dy dx is equal to 27 over 4, and then we can consider the point slope form to find the equation of the tangent. We consider this point 1, 7, and then the slope 27 over 4. As a result, the equation is 27x minus 4y plus 1 equals 0. This is how we can find the equations of the tangents from an external point.